Yeah, let me set up. So there's a lot of stuff we can do with transformation. So we're going to do a bunch of quick examples first, and then we'll add some animation. So this is our transformation example. And so when we're doing transformation, what we're doing is we're actually changing the basic settings of the canvas. If we look at the transform section, you can see there's a bunch of different functions here. We're not going to use all of these, but we're going to look at translate first, and then this is sort of the one we want to start with. But then we'll look at rotate, rotate X and Y. We'll look at scale, and we'll look at shear. Oh, it looks like they replaced. Oh, interesting. I think they changed. Oh, never mind. Okay, no, we're not going to learn this, but we'll learn push and pop. I don't see those on here. Oh, they're in structure. Okay. Anyway. So I'm just going to start by drawing an ellipse, or a circle rather, at the 0, 0 position of the canvas. Let's make it a little bigger. And so this is the default canvas. I'll put a little default here. And you can see that when we draw a circle at 0, 0, the circle is in that top left corner of the canvas. And we can only really see like that one sort of slice of the circle because the circle position grows from the center. So I'll put a rectangle here just so we can see another example. I'll put a rectangle at 2020, and I'll make it 100 pixels wide as well. Okay, so there we see the rectangle. So the rectangle draws from the top left, and it draws 100 pixels over and 100 pixels down. Let's just make it 50 actually, just to save a little space. So this is the default transform. A transform is sort of like describing the position and scale and rotation of an object in space. And the canvas has its own sort of transform. You may have seen this in, if any of you guys have ever done any 3D stuff, have you guys taken any 3D classes at all? Okay, couple of people. So when you're working in 3D software, you're more aware of this because everything in 3D, you spend a lot more time working with the transformation of different objects, so their rotation, position, and scale in space. In 2D, we don't talk about it quite as much because we're only dealing with 2 dimensions. So we just think about the properties rather than the collection of properties. But when we want to change the properties, we're changing, everything about the way that the sketch works when we change the properties. So we use the term transform to talk about this collection of properties that includes position, rotation, and scale. So I'll put a note here. So transform is collection of properties, position, rotation, scale. So if we translate, we're changing the position of our canvas. So translate changes the origin position. So if I translate, and I'm going to translate by 200 X and 200 Y, and then I'm going to draw the exact same thing. So notice that my code is exactly the same. Circle 0, 0, 100, rectangle 20, 20, 50. Same exact code right here. But it's in a different position because I've translated the canvas. Everything that I draw on the canvas after I make this translation is going to draw from a new origin point, which is 200, 200. So if I move this anywhere, like if I make this mouse X, mouse Y, just as an example, wherever I translate to, so I'm translating to wherever the mouse is right now, just as an example, that becomes the origin position of my sketch. And everything that I draw is related to that origin position rather than the original top left corner. And so this gives us a lot more options in terms of changing things like rotation and scale, because we can rotate around different points and we can scale into different points and do other things like that. So you could use Translate on its own to do most of the stuff that we've been doing throughout the semester. Like you could draw things in different parts of the canvas just by translating and then drawing there instead of using XY or instead of using variables. The reason that I usually wait to introduce this until later is because I want to introduce it with rotation and scale and all these other things at the same time so we can see how they relate to each other. Okay, so Translate changes the origin position. I'm going to set this back to 200. So then rotation rotates around the origin. So I'm going to do another example here. I'm going to rotate. And I'm just going to rotate by 1, but then we'll do some other stuff in a second. So then I'm going to draw the same thing again. So again, I haven't changed these parameters at all. I'm drawing the same circle and the same rectangle. Okay, so notice the circle looks the same because when you rotate a circle, it's a circle, so you don't notice the rotation. But the square has rotated around a little bit, right? And 1 seems like a low number. Like if I move the circle by 1, we're barely going to notice the difference. But for rotation, 1 is actually a pretty big number because we measure rotation in terms of pi. Have you guys heard the number pi before? Are you familiar with that? Yeah. So pi is 3.14 with a bunch of other stuff after it, and it represents rotation. So we use pi to measure. It's a constant that just happens to correlate with how we measure circles. And so when we're doing rotation, we rotate from 0 to pi. So if I rotate to pi, and when we do it in P5, we can just use pi, all caps, to represent pi. So if we rotate pi, that's 180 degrees. If we rotate pi times 2, then we go back to the origin. And then we can rotate in different amounts of pi. Like I could rotate pi over 2. That's going to be a 90-degree rotation, or over 4 would be a 45-degree rotation. So another thing I'm going to do is I'm going to actually change my circle a little bit here, or maybe I'll just draw another circle, and I'm going to move this circle away from the origin. So instead of drawing at 0, 0, I'm going to draw at 10, 10. And I'll make the circle a little smaller so we can still see it, but it won't take up as much space. Okay, let's actually move it a little bit farther away. Let's do 25. So notice the circle, when I move away from the origin, it also rotates. So if the circle is right on the origin, we don't see the rotation because the circle is a circle. We won't see that rotation. But if we move it away from the origin, then we will see the rotation. Let's make the original circle smaller. Okay, so we can see the circle is rotating around wherever the origin point is. Actually, let me put this little circle. Let me make this circle smaller up here. No, that's not what I wanted to do. This. Okay, so now you can see the circle rotates as well if it's, moved a little bit away from the origin point. There we go. So that makes a little more sense. And another thing about our transformations is that they're cumulative. So if I take this whole thing and I repeat it, we're going to see it rotates again, even though oops, transformations are cumulative. Do you guys know what cumulative means? It's kind of a big word. What? What? Oh, yeah. Yeah. It means that we keep adding to it. So it accumulates. So if we rotate once, that's our first rotation that we can see here. And then if we rotate again, it starts where we left off. So it keeps rotating. So even though these two rotations are the same, we see that we're rotating farther along the circle. So all the transformations are cumulative. If I translate somewhere and then I translate again, we add those together. So then we can also scale. So maybe I'll put a scale. Where should I put a scale? I'll just put a scale here. I'll say scale 2. And then I'll scale 2 again. Okay, so notice now I'm rotating, but I'm also scaling. So my shapes are getting bigger as I scale up. If I scale down, like if I do 0.5 and 0.5, we're going to scale in. So scale scales the entire canvas, and it scales all the drawings, all the shapes, and images, whatever else I'm drawing. It scales them as well. Okay, so let's go over one more thing. So because our transformations are cumulative, if we have a transformation, a group of transformations that we add to one section, but we don't want it to affect another section, we can use push and pop to save our canvas setting and then release it. So this little spiral thing, if I want to leave that as is, but I want to do something else somewhere else, what I can do is when I start translating, let's actually do it after our first translation. So when I start here, I can push. So when I push, basically what I'm saying is add this transformation to a stack. And we don't really see this, it's happening in the background. But a stack in programming is like a stack of pancakes, but instead of pancakes, it's information. So we have a stack of transformations of what the canvas looks like, and we can push new transformations onto the stack. And if you push it onto the stack, then you can take it off. So just like when you make pancakes, you stack up your pancakes, and then when you eat them, you eat off the top. So if I push the transformation onto the stack, then I can pop it off and go back to the previous transformation. So push adds transformation. It's hard to spell. This is a long word. Whoops. To a stack. So everything that we do after push is in this one transformation pancake stack. And then when we pop, this pops off the last transformation from the stack. So we go back to wherever we started here. So now if I draw another circle here, you're going to see that this circle is on back at our previous transformation. And I'm going to move it over a little bit, so I'll put it at 100. And let's put it at negative 100. Notice that negative 100y is now inside our canvas because 0, 0 is in the middle. So if we go negative on y, we're actually still in the canvas. And so you can see that all these rotations and scales that I did no longer apply. And so I can do a different rotation. So maybe I'll rotate. And this time I'll rotate negative pi over 4. And so notice that rotation is still happening from the origin, even though my circle is farther away. It starts up there. And maybe I'll do this a few times. And so we get this other rotation. And I kind of want to start it here. So I'm going to actually do, well, let's clear that first rotation. Or actually, let's do pi over 4. There we go. That's kind of nice. So we'll start at pi over 4 here, and then we'll rotate negative pi over 4, rotate negative pi over 4. So we can have a whole separate transformation that we apply after we pop this previous one, and we can do that as many times as we want. We can even do it inside of other transformations. So you can push and push and then pop and pop. We won't get too crazy, but those are just a few examples. So that's transformation. It's a little, it kind of changes the way we think about things, so it can be kind of confusing at first. But you don't have to use it unless it's going to do something that will help you, realize an idea that you have. But we can animate this, so that's where it's going to be a little bit more fun. So why don't we try animating? And I'll do a couple different examples just because it starts to get complex pretty quickly. So I'm going to save this one, and I'll add it to our class collection. Any other questions on the transformations before we add some animation to this? All right. So I'll leave that there, and we'll make a new project. And for this one, we're going to animate rotation. Okay. So what we want to do is we're just going to transform our sketch, and then we're going to animate rotation, and then we'll see if we can do it in different ways. So I'm going to translate to the middle of the canvas to start, because we're going to rotate around the center of the canvas, and I'm going to draw a rectangle, and I'll move it a little bit away, so I'll do like 25, 25, 50. Okay. So now if I rotate X, and I'll just throw frame count in here for now. Oops. Oh, never mind. Sorry, that's for 3D. Okay, so if I rotate frame count, it looks kind of crazy because it's rotating so fast that we're only seeing like little clips here and there. And remember, that's because our rotation is measured by pi. And so a full rotation is just 2 pi. So we're rotating way faster than what makes sense for this method. So let's try something else. So instead of using frame count just counts up by 1 each frame. Let's do the same thing, but with a variable. And instead of counting up by 1, we will modify the variable. So I'm going to create a variable called R for rotation, and we'll start it at 0. So we'll use this to animate rotation. Okay, so then I'll say R equals R plus, and we'll use something smaller. I'll start with 0.1, and then we can modify that. So now we got this rotation going at 0.1, and that's actually not so bad. That's pretty smooth. If we go slower, then it's going to be really slow. And notice with this rotation, it resets. Because it's a rotation rather than a position, when we get back to 0, instead of going off the side of the canvas, we're just back to where we started. So with this animation, we don't really need to use the same code to reset it. But, of course, we could. So what if we wanted to rotate all the way around and stop and then go all the way back? We could do the same thing we did in our previous lesson with speed, but we'd have to measure for something else. So let's make a speed variable. I'll call this R speed for rotation. And I'll use maybe 0.05. And then I'll replace this value with R speed. Okay, that's pretty decent. But let's measure, and when we get back to where we started, we'll reset. Okay, so we can say, so one full rotation around a circle is 2 times pi. So we can say if r is greater than pi times 2, we can say r speed equals r speed times -1. Okay, so just like we had before, we can control the animation by testing for these different positions. And you don't have to go all the way around the circle. I could just check for pi. So I could just go to there and then go back. Of course, it's not going all the way back, so we'd have to set a check for or r is less than 0, but looks pretty much the same thing. And so now we could do like, you know, it kind of looks like a metronome or a clock or something like that. So with our rotation, we can get different effects, but we can use the same basic structures to control the animation. All right, let's do a scale example. And then we'll look at shear for a minute as well, because that's kind of fun, but it's a little confusing. Any questions on our rotation example?
So the rotate, it's like it's taking the top left of the square, and it's rotating the rectangle itself and around position it started at.
It's rotating the entire canvas. So the rectangle is on the canvas, and so it appears like the rectangle is what's moving, but no matter anything else we draw, like if I draw other stuff, if I draw a circle, you know, with the same parameters, that's going to be part of the rotation as well. So what we're rotating is the entire canvas. It's like, if you can imagine what we're drawing on is like a physical painting, like a canvas. It's like if you picked it up and rotated it. Other questions? All right, let's see if we add to this a little bit. We could make maybe r times 2. Okay, that's kind of fun. So we can take the same value and, you know, add to it to get more variations. We could do this a bunch of times. So if you can see how this can get pretty complex pretty quickly if we start to layer transformations on top of transformations. You can get some cool patterns and cool animations. With the rotation, especially since everything is turning around and resetting, you can get some kind of cool effects. All right, let's do an example with scale. I'm going to save this. Oh, it's not letting me save. Let me copy and paste and then. Okay. Okay, let's add that to the class collection. Okay, and let's do scale. Uh-oh. So same thing basically here. Rotation is a little bit more challenging just because we're using pi as our measurement. But with scale, it's kind of the same thing, except it's not going to repeat. So we have to be more careful about how we control it. So I'm going to use a s variable and start it at 1. And so this will be my scale animation. And same thing, I'm going to translate first. So when you're using transformations, often we'll see translating into some position first before we start to do our other transformations. So let's draw a couple rectangles around our origin. I'll just kind of put them on opposite sides of each other. And then if we scale here, so I'll scale by S, and then we'll animate the scale. So I'll say scale equals S plus, you can use a small value again. So again, we get, this animation of scaling into these rectangles. We could scale and rotate at the same time. That might be kind of fun. But we can, again, we have a lot of options. We can just, one of the things we have to do is think about what we want it to look like and then design the code to work that way. So we could scale up to a certain point and go back, or we could reset. So if I wanted to just reset, I could say if scale is greater than 2, set scale back to 1. And now we'll get this kind of like techno-y bouncing effect. Maybe we could do scale as 4. And then once we have this kind of set up, there's this relationship between the speed of the animation, which is this value here, how much we're increasing, and then the boundary of the animation. So if I make this faster, the whole animation is going to be shorter. So we don't necessarily have to, bounce off of things or reset or go back in the other direction. Sometimes we can just reset. We could do different values. We could do random speed. So I could say like random 0.5 here, and we'll get different animations based on randomness. It's kind of cool. Let's add a few more rectangles just to balance things out. Okay, that's kind of fun. So yeah, that's an example of scale. So let's talk about shear, because that one's a little bit more confusing, but we'll look at a couple examples of that. Any questions on scale? All right, so our last example will be on shear. So shear is sort of like if you've ever used Photoshop and you've used like the skew, like when you have an image and you kind of drag it out to the side and it kind of like skews the image. That's basically what shear is. So I'm going to translate to 200, 200. And I'll use some text for this because I think it makes it easier to see what's happening. So I'll draw some text. I'll write shear, and I'll put that at 0, 0. And let's do text align center, center, and text size is 100. Okay. So if I shear X, and shear is measured in rotation, so we use pi again. So if I shear X by pi, we don't see anything. If I shear pi times 0.5, so if I do half of pi, then we still don't see anything. But if I do by a quarter of pi, we see this sheared version. So what happens with shear, and when I move the text, you'll see how this works. So I'm going to change the text align for a second. So instead of center, center, I'm going to do center top. And let's make it a little bit smaller so it fits on the canvas. Okay. So I'm doing shear X by a quarter pi. And if I move the text on the X axis, you can see it just moves along X and it stays basically the same. If I move on the Y axis, see how it moves at an angle? So when we shear on X, we're really rotating on Y, but we're only rotating the part of the graphic that's farther away from the origin. So it's kind of hard to explain, but you can see here how that works. And I can visualize this a little bit better if I say let y equal map mouse y from 0 to height and 0 to pi. Oh, wait. Sorry, I want to do this up here. Okay, so now you can see what happens if I map this to the mouse. So as I'm moving the mouse down, remember 0.5 was it disappeared. That's because we've rotated all the way up, so it's just like a line. And then it kind of comes back around the other side. So we're basically changing we're really just rotating and moving the bottom away from the origin. But the effect is that it kind of looks 3D, like it's rotating in 3D space. So if I get halfway down, it's completely invisible because it's like flat. And then it comes back from the other side. And then if I go all the way to the bottom, which is pi, then we see it come back. So that's one example. We can also shear on X. So let's do an example. I'll push and pop this. And I can also put things like text align inside push and pop. So let's grab this, and then I'll just do the same thing, but I'll align it the other way. So I'll align it on the bottom. Uh-oh. Oh, I'm redeclaring y. Or no, I'm already doing this. So let's do let x. And so this time we'll shear on y. And so you can see it's kind of the opposite. Let's go up here so it's not too crazy. Maybe it's too crazy to look at both of them. Oh, I put in the wrong thing here. Okay, here we go. Okay, so maybe I'll put shear y and shear x. Okay, so shear y, when I'm moving x, we get the same effect, but now it's happening on the y-axis instead of the x-axis. So when we're right in the middle, it's like completely flat, and then we get to the other side, it goes back to where it started. And then when I go up and down, you see that. So shear is kind of confusing, but you can get some kind of cool effects if you can, kind of figure out how to use it correctly. So I'll leave that there. If you guys want to use it, you can plug in an animated value instead of a mouse value here to get an animation rather than an interaction. So you could play with that. You can get some kind of cool, effects with this, but it's a little bit harder to control. All right. So those are our transformations. Any questions on any of the transformations or any of the other stuff that we've covered? Okay. So I'll add this example to our class collection.